All right, stat students. So we're continuing with our probability section today. Quite a bit of notes last time, a lot of writing. Or last week we had a lot to write. There's some longer lessons, but we got the introduction out of the way. Now we're really focused on just sort of learning skills. Probability can be pretty challenging. I'm going to go ahead and make sure I say that. So you need to make sure that you're asking questions about particular problems. Make sure you're practicing on this the problem set. I think I said you could do through 27. There's actually quite a bit more questions that you can look at. There's a few things that you're missing within these. Looking at some of these here. We need to learn more about independent events. So, chip away at what you can. If you're confused on a problem, just save it but look at it, read it, see if there's confusion, and maybe you can come back to it later. Put a star beside it, something like that. But make sure that you're using that as a main tool for studying these examples. That's why we moved to these problem sets. Okay. All right. So we're going to go ahead and get things started for today's lesson. All right. So in your notes, you can draw a line, and we're going to draw a line and say displaying sample spaces. We've talked a lot about sample spaces. We've created one with the dice rolling, and we did the two dice being rolled, and we made in that example we used a two-way table. So two-way tables, which we've already dealt with this year. I think our very first unit is the second unit, we actually used two-way tables, and that was sort of with this section in mind. Okay, so with two-way tables, we already know how to construct those, but I'm going to have you go ahead and create a two-way table with me. Typically with two-way tables, you have two events, and we can write them up this way. So I want you to go ahead and do this, and let me make sure I've got this correct before I write it in here. Hold on. So this is typically how you're going to write up your events, and you can label them however you want, but we're going to go ahead and draw some lines to our two-way table. And if you remember, in two-way tables we had our totals on the margins. So we had margins, so this is totals, total. Okay, and we're going to say this is event A and this is event B. Okay, and then we have that symbol. We wrote it down in our probability rules, the complement rule, right? We have not A and we have not B. Writing up situations like this is so helpful for you guys answering questions A, not A, B, not B. Okay, to organize the outcomes, the sample space of a problem. Okay, that'll help you a lot on the problem set for many questions. Now, I won't say every question, but almost for most questions, you can set up a two-way table like this and fill it in. Okay, so our example is going to be, we're going to have this. So we have A is that you are male. B is pierced ears. I know I'm going to spell this wrong. I before E, right? English people. Pierced ears. Okay, so A is male. B is pierced ears. So we have A, these are all the males. B, this is all the people with pierced ears. Not A would be people who are not male. So typically we're going to think female for that one. And then not B would be people without pierced ears. So we're going to fill in some numbers. So I'm going to go ahead and we're going to use this example here, okay? And go ahead and fill in your chart. Now, we have this as A, not A, B, not B, but go ahead and put in all these numbers, okay? So 19 males have pierced ears. So that's that A and B, right? Then we have, just go ahead and fill in all the numbers. I'll give you a second. I'll pause it, and you can do that. All right, so now we have these questions. So we defined events A as male and event B as pierced ears. So first question up here is what's the probability that they have pierced ears? So now that we have this copied down, let me actually go ahead and let me take that, snag that, and put it into our notes here so that I have it. Paste. There we go. Let's move that over here. Okay, so we've got our event. And let me go ahead and fill that in. So you should have this on yours. So 19, 84, 71, 4, 1, 3. And again, we've dealt with two-way tables before. We know how these should look. And so we have our very first question, which is going to be probability that they have pierced ears. So this is how we write this. So probability of A. So I'm going to go ahead and pause this. I want you to try to get your answer, okay? Go ahead and try to answer that. All right, so for probability of A, this is the probability that they are male, right? That's what we wanted to find. Probability that they are, oh, I got that wrong. It's probability of, whoops. Probability of B, pierced ears, whoops. Let's pause it again. I'll make sure that I didn't pause it before this, okay? So let's pause it again. Probability that they have pierced ears. Okay, so probability of pierced ears, you have 103 people out of 178. So if we were to do like a random sample per se, that's kind of what the context is here. Taking if I randomly chose somebody from this or this sample here of males and females that produce this data, we would have 103 people out of the 178 that would be would have pierced ears. So we're just going to use our calculator, 103 divided by 178 to create a decimal. And I always, here's my rule for it, always round to 4 places and you'll never really be wrong. So we say 0.5787. 0.5787. If the question needs fewer decimals, then you can just round this to where it wants it, okay? But this would be our answer to number 1. All right, number 2. Number 2 says we want to know, is a male with pierced ears? So probability that they are male, so that's A, and have pierced ears. So now we have this idea of and. We want both. The probability, they have to be male and they have to have pierced ears. Let's scroll back up. Let's pause it and let's see if you can get the right answer. All right, so how many people in this distribution? So I'm going to randomly pick what's the probability I get a male who has pierced ears? So both of those requirements have to be met. Well, that's this part right here. Okay, that's where both events occur. So that's 19 out of 178. A lot lower probability of actually getting that. 19 out of 178. So 0.1067 is going to be our answer. That's with the rounding to 4 places. So 1067. Okay. Hopefully that makes sense. Both requirements had to be met. We wanted both. All right. Okay. So is male with pierced ears. All right, next. Is a male, and we have this word or, has pierced ears. So how does that change things? That's what we want to know. And I talked about already how important this word and is. And now we're going to compare it. So probability that they are male or they have pierced ears. So how does that change this question when we want the or statement? It doesn't have to be both, but it could be either, right? That's sort of how you interpret that. So let's see what you come up with. Male or has pierced ears. I'll pause it. Okay, so we know that they can be male, and it satisfies one of our requirements. They just need to be male. And there's 90 of those, right? 90. And then, or if we just pick somebody with pierced ears, it could be a female with pierced ears. It doesn't really matter, but there's 103 of those, okay? So let's talk about a possible option that some of you probably would have done here, okay? Some of you would have said, oh, well, let me just add, and I'm going to write this in red because this isn't the correct way to do it. Some of you would have added 90 and 103, and you would have got, oh, you would have seen there's an error, right? Why can't this be an option, right? Well, this is greater than 1. And we already said in our rules for probability that that can't happen. Any event right here, it doesn't matter what the event is or if it's a combination of events, it has to be between 0 and 1. So we run into an issue here for this scenario. So maybe you can see what happened, right? What exactly happened here? Well, what happened was we double counted this 19. So if we take away 19, we're going to get the right answer. Okay, so 193 subtract 19, 174. Okay, so let's write that. We'll say this is the right answer. 174 over 178 is going to equal the right answer. Okay, and that's going to be less than 1. But so that's a legitimate probability that we could get. So we have an issue here with these events where we have sort of this overlap, if you will, where these two requirements are met. So we have to make sure that we get rid of that. Like we don't have that happen to us. A couple ways that you can do this. If you remember this, whenever you're doing the or statement, you don't want to double count the center part, right? You don't want to do that. So a lot of times what I do is I just add these three. This is sort of the elbow here. We don't use this one, but it's these three spaces. So it'd be 19 plus 84 plus 71 is what I would do. So there's that 174. So over here we'll do 174 would be the total options for us. 174 over 178. What is that? Let's go ahead and do that calculation. 174 over 178. So 0.9775. That's almost everybody. There's only a few females that don't have pierced ears in this distribution. So this is not male, or that don't have pierced ears. So not male and no pierced ears. So there's 4 females that don't have pierced ears. So that's sort of the question type. So this is going to be super helpful for a lot of questions on your problem set. If you have this and statement, this or statement, it's very helpful to try to put the situation in a two-way table. Two-way tables, I would say, are the most useful tool that we have in this section. Okay, they're going to help you so much on the test. All right, but there's one more way that we're going to be displaying sample spaces, and I'm pretty sure that you've drawn these maybe in other classes, but we have what's called Venn diagrams that we can use. And Venn diagrams relate to, actually go pretty well with two-way tables. So I'm going to try to drag this down as far as I can. Usually this stops me from doing it. Yeah, let's go ahead and we're going to start a new page actually so that I can have this. Because I want to compare it to our two-way table. So let's paste that back in, move that over. And then so you need to, you don't have to draw a line actually, because now we're going to talk about Venn diagrams. The last part of our notes that we'll be writing today. So a Venn diagram, as you know it, is going to be, and I get to cheat because I can draw my own circles, right? So we have 2 circles, and just to make sure that these are the same, I want to, can I duplicate this one? Copy, yep, and then paste. So you can have fun drawing your own circles. But there is what a Venn diagram looks like, except this one's actually not complete yet. You always have to have a rectangle around it. I don't really need that to be red. Let me make it black. So the box on the outside represents the entire, we have the sample space. That's everything, right? That's possible. I almost want to put that on the outside. Hold on. Write that on the outside. Sample space. Remember, the sample space adds to 100%. And so we have these events. This is A, not A. B, not B, right? So what we do is we label one of these as A and one of these as B. And now we're going to take this table over here and put it into the Venn diagram. Okay, that's what we're going to do. So here's the question. What is going to go in the center part? Well, that's where both events occur. This is going to be that 19. Okay, so it's super important that you know how to convert from a two-way table to a Venn diagram. Okay, it's going to be super helpful for some of these problems in your problem set. Next, we want to know what goes over here in this blank space. Well, here's what a lot of students mess up doing, and they put a 90 in here. But that's not true. Okay, 90 is everything. The entire circle for A is a 90. And if we did this, so watch, if I put the 90 back, actually, let's put 90 back. What's 90 plus this 19 here, which is still part of that circle? Well, that's 109, but that's not how many males we have. This here, these are the males that do not have pierced ears. So there's actually 71 of them. So now 19 and 71, they add to get 90. What about B over here, this big space? Well, these are the just the people that have pierced ears that are not male. So that would be 84 females. And you'll notice 84 plus 19, that's going to add to this 103 here. So these two, they're right here. These two add to get the 90. So you can see how we're sort of translating it into this chart. Now, where does the 4 go? That's my question. Where do I put this 4? Where does that end up? That's what I want to know. Well, that ends up out here where it's in neither of those events. It's outside of those circles, right? Well, and what do we notice about the entire sample space? What happens when we add up all 4 of these numbers? Well, that gets us this 178. I'm going to put that on the outside. 178. So there's 178 individuals, and we've broken them into these 2 events. That's very important, understanding how to display these sample spaces. And now we can answer questions from these Venn diagrams. Now, oftentimes in the past couple of years, students prefer the two-way tables. Honestly, I do too. I think they're great. They're a lot easier for visualizing, I suppose, than these Venn diagrams. Venn diagrams can be a little bit more confusing, okay? But we're going to write down some notes for Venn diagrams. So get ready to write, and you're going to draw some diagrams for me, okay? And do some shading. You're going to draw several more of these, okay? So let's go ahead and start with, we have our answers here, good. Okay. So we've talked about this idea of the Venn diagram. So event A and B always occur in the center. Event B is the whole circle. Event A is this whole circle. All right. And then if you want to know the probability of either event happening, so let me get back to that actually. That or statement that we had would be all 3 of these added together, right? Remember we added them all in this little corner? That would be the or statement. That's all 3 numbers added together. But we have some rules that we're going to write down. So let's go ahead and start with this. So for Venn diagrams, the first rule. So Venn diagram probability. They have uses in other branches of mathematics down the road if you decide to study more math. A lot of face-to-face learners haven't expressed interest in that. But let's start with this first rule. The complement. I need to underline some more stuff. So let's underline this. All right. The complement contains exactly the outcomes that are not in A. So if we say not A, it's everything else. The probability of not A happening, everything else. Okay, so we'll go ahead and write this after. I'll pause here in a second. The next part, we have this idea of mutually exclusive, which we've written down, but this is what mutually exclusive events look like. They don't have outcomes in common, so you have to separate them. The circles are not going to cross over each other or intersect, which we're going to write in a second. So I'm going to give you a moment to draw. You need to sketch both of these, by the way. Write the wording, sketch both, all right? Sketch both. Okay, so we have these rules here. Mutually exclusive, very important that you understand how that's working. They don't intersect. Next, we have what's called the intersection, and this is very important. The intersection of events, and we have a new symbol that's being introduced here, and I need you to write that in there. So it's the intersection of events A and B and we have this A, and we call that A and B, set of all outcomes in both events A and B. You're going to draw this diagram, and I need you to shade the middle part, because whenever you see the and statement, you know it's where those two circles are overlapping. I'll go back just to make a point. What would be the probability both events occur at the same time in a mutually exclusive example? Well, that'd be 0. And we actually wrote down that rule. Let me keep going back. We wrote down that rule here. A and B is 0, right? A and B is 0. Then we have this other one, addition rule. For the or statement, you're just adding them up. So remember how we said for the or, either one happening, we would add all 3 circles together. Here, we just add the 2 circles together, okay? We can just add their probabilities, and it works. Either one happening, you add them together. I'm throwing a lot of rules at you. Anyway, back to this one, intersection of events. You're going to write that down. And then we have the union, okay? This is very important. The union of events. This is the or statement, right? So we have a huge difference between and I need to underline some more here. And statement. Come on now. What the? And then you have the or statement. And an or. So we have these new symbols, and the key to keep those symbols straight, remember this U here, the opening up like a U is union, and opening down is like for intersection. So let me, you're going to copy these down. I keep going in and out of my PowerPoint. I'm sorry. I'm going to pause it. You're going to write these. Okay. And so in your notes, let's make sure that we write this down. So we have U is union, which is or statement, the union of the events, either male or pure steers. And then you have this, which is intersection. As the and statement, either one occurring. And you have the upside down U, which looks like sort of like an in, intersection, okay? And now we can write our events a little bit differently, okay? So we say, let's look at an example like this. So what's the probability of A and B? Well, we know that's the intersection where they occur. It's 19 out of 178, okay? Probability of, let's say, not A. Well, everything outside of A is in that. So that would be not including the 19 here, right? That's everything other than 90. If we go back to our chart, which might be easier, it's the probability that they are not male. Well, how many not males are there? Well, there's 88 individuals who are not male. Okay, and this is how we're writing a lot of these events with the complement rule. Remember the little, we'll say C means, or is complement. We'll say complement. We'd say not A. I've already written down that rule before, but that's important, okay? So it's everything that's outside of this circle over here, or everything other than this event. So it's the 88 right there, okay? So hopefully that makes sense, and we now have these different displays for Venn diagrams that we see. Let's talk about some of the examples here. Here's an example here. So in this scenario, which one represents A or B? So we have the events up here, and we remember the union is all 3 of these spaces added together, okay? Now you can't answer 67 yet. We haven't talked about this symbol and this notation, but you can answer 68, the probability associated with the intersection of A and B. Well, where's the intersection? Well, that's this middle part, right? So we now have those rules that we can use on Venn diagrams. We have this right here. 61 and 62, you should be able to answer those. We can't do this one yet. There's another way that they have Venn diagrams displayed in here. Oh, here's a Venn diagram. Just because it's rectangles, that doesn't change anything. It's just a different way to represent Venn diagrams. You can imagine these as circles, right? If it helps you to visualize, turn the E and F back into circles, and you should be able to answer the question. You'll notice that there's shaded regions in here. Same thing for number 50. So 50 and 51 you should be able to do. Some of these other ones you're gonna be able to do. You're just gonna have to think through them. Okay, you're just gonna have to think through them. It can be a little bit tricky. 37 and 38. Here's where I would probably draw a two-way table. Let me show you how you could do this. Okay, because 37 and 38 are going to be similar. I will work this example with you all. Let's do that. And how it's 25 minutes in. That's not bad. So this is how you'd want to do one of these. Okay, let's go ahead and draw. If you want to in your notes, write this down to 37, 38. We'll answer this together. We have A and not A, B and not B. And we know the totals are going to go out here. Now, the thing that's different about this one is that we're dealing with decimals. So we know that probability of A is going to be 0.2. Okay. Probability of B is going to be 0.4. That's going to go here. So we have to make sure we put these in the right spot. Remember, these probabilities are totals. Okay, these are totals. So actually, I don't think we can answer this because we need to learn more about independent. But this is the idea, like you could set this up. But I will go ahead and ask this question. What would be the value that's in the bottom right? Well, that would be 1 or 100%. That's the whole sample space. So that gives us this 0.6 and this 0.8 here. Now, we don't have any of this other info inside of the two-way table, but this is how we could start to think about some of these questions. Again, we're gonna have to learn a little bit more about independent, but we'll get to that. But that's at least a setup that we could start with. Let me find one that we can actually answer pretty easily with a two-way table. There's not a ton. Let's see. I don't want this idea of independent yet. We're not ready to go into that. That one either. I want one that's more just like, here's event A, here's event B. Find these probabilities. Looks like this one doesn't have the example that I want. Yeah, looks like I'm not gonna be able to get one like I want. Maybe I'll find one in the book somewhere that we can do for the next lesson. But okay, we're gonna go ahead and stop here and look forward for another lesson in a day or two.